Hello and welcome to computer class. My name is Dave, and today we're talking about computer components. This is the part one, and we are talking about motherboards, processors, memory, and hard drives in this lesson. But before we do all that, I want to give you the definition of a computer. So, what is a computer? Well, according to the web, it's an electronic device operating under the control of instructions stored in its own memory that can accept data or input, process the data according to specific rules, and produce information or output, and store the information for future use. Now, that definition is kind of a long definition, so I want to give you a video to explain it. I'll link that down in the description, and I'll give you another video that could also help you help you understand what a computer is. And then I want to give you a simple definition of what a computer is. And this is my favorite definition. So I use it constantly when I'm talking to someone about computers. But I think a computer is this: a programmable device that can store, retrieve, and process data. It's the simplest, easiest definition to remember from Merriam-Webster Dictionary. And then a mobile device, I would say, is a computing device small enough to hold in your hand. We abbreviate the term computer as PC. If it's for someone personally, we say personal computer, and that's what PC stands for. That's what the acronym stands for. All right. So there are many types of computers. As we get into the different parts that are in a computer, there's desktops, laptops, servers, terminals, smartphones, digital cameras, ebook readers, portable media players, gaming devices, embedded computers such as ATMs and in automobiles, planes, space vehicles, machine tools, GPS navigation, you name it. The sky is the limit. There is so many different types of computers. However, we need to talk about the parts that are in a computer. The first part of a computer, and there's, I would say, 8 major ones. Maybe you could add on 2 extra ones and make it 10. But the first component that I would say that is needed is a motherboard. Um, and again, I'm talking from more of a PC basis, so I'm talking more of a desktop computer or a laptop computer, something like that. All right, so a motherboard is the main circuit board for a personal computer. Many electronic components are attached to the motherboard and others are built in. So as you can see in the picture here, we've got lots of different channels, and those hold our RAM sticks, which I will talk about in a second. In the middle, we have a big square, and that is where the processor sits. And then we have these lines going this direction horizontally, and that's where your graphics card would slot in. And of course, there's lots of different connectors and I/O on the back side that you can't see facing this direction, where you plug in maybe your HDMI cord or your USB dongle devices or different things that you could plug into the machine. Needless to say, the motherboard is where everything attaches. Okay, and so what I'm going to do is I'm going to link some videos down in the description of how motherboards are made because they're really cool. This is the Gigabyte Factory. And then another guy talking about the Gigabyte Factory, how motherboards are made. And then I'm going to give you the second component of a computer, which is a processor, otherwise known as the CPU or Central Processing Unit. It is an electronic component that interprets and carries out the basic instructions that operate a computer. And there are 2 major types of CPUs or central processing unit companies that make CPUs, and they are or sell CPUs, I should say, Intel and AMD. And they're kind of, people would term them, Intel would be blue versus red is AMD. People talk about them in color terms, so to speak, of blue versus red or red versus blue, depending on how you look at it. But anyway, Intel and AMD are the 2 major companies. Now, they're not necessarily the ones that manufacture the chips, they're the ones that sell them. Global Foundries is a big deal. They sell a lot of chips to these companies who market them. So what I'm going to do is explain that a processor is made out of basically silicon or sand, and I want to give you a video on how they are made, because there's no way I could explain the total process. So I'm going to link down in the description this video on how CPUs are made, and also this video from Linus Tech Quickie actually on how things are CPUs are made. And then here's a technical video. I don't think you necessarily have to watch this all the way through, maybe 9 minutes in. It explains kind of the technical on how CPU actually works. So that's pretty cool. And then this one explains how they've shrunk down the microarchitecture of the processor. So watching all those will take you some time, but they're definitely worth watching. And then here's another one of the videos on the next level of what's coming for processors. And so definitely take some time to watch all of those videos. Okay? That being said, once we move past the idea of the processor, we're still on it though. Um, what is a CPU core? Well, um, computer processors nowadays have these terminologies attached to them when you go to buy them. They're like dual core, quad core, octo core processors. Some even have 12 core, 16 core, 18 core, 24 core. On and on it goes. What is a core? That's the question. And so basically a core is um, it's a central processing unit or a separate central processing unit that works in tandem with the other cores to process data. So basically they take and they kind of trick the computer, so to speak. They have multiple processors working side by side on the same die. And using software, they're able to kind of manipulate and make sure that they all work together, and as a result you can process more at once, is the simple explanation of it. So it's almost like having this processor is next to this processor, which is next to this processor, next to this processor, and the more cores you have, theoretically the more programs you could run at once, theoretically. So if you had 4 cores, you should be able to theoretically run 4 processes at once, 4 separate processes. So you might be able to have Microsoft Word open, Google Chrome, maybe some, I don't know, like other piece of software open, like a game, and then maybe, PowerPoint. You have 4 programs open at once, in theory. Now, your computer would run pretty slow if you did that, but nonetheless, having multiple cores does give you the ability to open multiple programs at once without having some sort of a processor catastrophe of everything kind of freezing up on you. Okay. Nowadays, I think it's pretty standard to have, in at least in the nice computers, 8 cores. If you have like a gaming computer or something, maybe 12 cores. So 12, 16 cores is pretty typical if you have a gaming machine. The other thing that you can see on this diagram here, which is a little bit unique, is it says shared L3 cache. And I don't know if it's on the next slide or not. I think it is. First, watch this video on what cores are. He really explains, I think, the difference between cores and how they work together and how you can process data, if you will, with different, it's more of a software-based division of the processor. But he explains more about that. All right, the third component is memory, and I'm about to talk about cache that's on the processor from that former slide in the memory section here. But memory consists of electronic components that store instructions waiting to be executed and data needed by those instructions. So basically what RAM or memory is, RAM, random access memory, is it's a stick that slots into the motherboard, like we showed you at the beginning of this video, and it holds programs that you open and runs them essentially. So for instance, when you boot up the computer, and then you double click on your Chrome browser, that program is loaded into RAM. If you double click Microsoft Word, it's loaded into RAM. And then if you were to save your Word document file, that will be saved to the hard drive. That will not be saved to RAM. RAM clears every time the computer is shut down, so it gets wiped and it starts over. It's short-term memory, if you remember back to our lesson previously, a couple lessons ago. So memory is short-term, storage is long-term, is always how I look at it correctly in my room. And random access memory gets wiped every time the computer gets shut down. It's what you load your programs into. Okay, and there's the definition for it. Random access memory contains all the data that is being processed by the CPU. Why is RAM called random access memory, you may ask? Because sometimes instructions are loaded into RAM randomly, and other times they are loaded in order depending on the user's request for the type of data needed. So as an example, the computer might be, upon booting up something, and it's not fully booted up yet, it's not fully opened, it's not fully all the way ready to go, but you start double clicking as soon as your computer screen comes up, you start double clicking on the browser, for instance. Well, immediately it loads that randomly into the random access memory first to be loaded because that's what the user wants. And so even though something else could be going on, because all this boot up stuff is happening, it still loads that program as fast as it can first. So again, random could be randomized. This is a video explaining about RAM. I know I have a lot of videos today, but it's because I don't have a lot of stuff, if that makes sense, to show you, but there's people specifically that are talking about these issues, so I'll link these videos down in the description for sure. Then you should understand that there are two types of memory. Okay, so the first is random access memory, but the second type is cache. Cache is a special high-speed random access memory that can be accessed more quickly than regular RAM, and it sits on that section of the processor. So the processor is like this square component, and you have these logical cores that are on there that are working together to do all the processes that the computer needs and making all the calculations and showing all the stuff to the screen, doing all these things that's going on the computer, opening different programs that you ask for, saving files and such. And then you load all of these things into RAM. Well, first it fills up cache memory on the actual processor because it's the closest to the cores. Once that completely fills up and you can't fit any more on it, it moves over to RAM. And the random access memory fills up. If that ever fills up, which isn't supposed to happen, and it probably never will, but let's just say you have a computer with 2 gigs of RAM and there's not enough RAM and you open too many programs at once. If that ever fills up, it moves to, if I'm not mistaken, the hard drive. It'll actually use part of it as what's called swap space. I guess if it's set up, I'm not exactly sure what happens. Usually the computer just freezes because it just can't do it. There's not enough space to load the programs that you're asking for. But this is the first set of RAM, if you will, known as cache, that will have stuff loaded into it like programs, for instance. Okay, so there's cache, not like money, but cache, C-A-C-H-E, cache memory. And then there's random access memory, goes in the slots on the motherboard. And then I guess if everything else fails, you default to whatever's left, the hard drive, I guess. Okay. So then we have the hard drive. Hard drive is a storage device that contains one or more inflexible circular platters that are used for magnetic particles, that use magnetic particles to store data, instructions, and information. And talked about the hard drive before when I talked about storage, but it's the fourth component, I would say, if you were to build a computer, put it together, what main parts do you need? Probably 8, but this is the fourth one. A hard drive. So I already talked about the 3 types of hard drives. You have HDD, hard disk drive. That's this one right here on screen. You have the SSD, solid state drive, which is flash memory. Go back and watch that lesson if you want to know more about this. And then you have the M.2, the latest and greatest thin little hard drive that's very efficient, that is up and coming. So anyway, these inflexible platters, if you have an HDD, are storing things magnetically. Again, it's more of the legacy old hard drives, but nonetheless, it still exists. Okay, so a hard drive be the fourth component of a computer. Good tips for hard drive is to keep about 10% of your hard drive free. I've actually seen a hard drive that's completely full, and they don't work very well. They start to crash. If you fill them all the way up, they will crash, and then you probably won't be able to access your data. You have to get some professional to get to it. Number 2, Back up your hard drive regularly because if it does crash, if it's an HDD and it crashes, or even an SSD can crash, not really crash, but like corrupt. M.2s can corrupt. They're known for corrupting. If you back it up, then you'll have your data and you won't have a problem there. Defragment your hard drive regularly. Make sure that it is, as we said back in the storage lesson, make sure all of the platters are aligned and things are in good order on the drive. All right. Lastly, I'm going to link this video down in the description. It's a future with good components by Intel. And so hopefully you've enjoyed this lesson about discovering computers, and I will see you in the next video.